Hey guys, welcome to this live stream. My name is Williams, and this is an entry part of the Learn C# Masterclass. Okay, I'm just going to do some housekeeping, so I'll be right back, and then we're going to swing straight into this. I'm just off screen preparing a few things, going to share the link. Yep, looks like I'm online. Excellent stuff. And yeah, just going to share the link while I'm offline on my Instagram handle, and also going to update the Telegram channel. As you can see on the right hand side, the one-to-one C# mentoring program is now in pilot, as is the Learn C# Masterclass. And the seminars and workshops for these are going to be freely available on YouTube and Telegram. So do keep in touch with things. Again, I'm just sharing the link offline. Sorry, not offline, off screen. So do excuse if you hear some sounds to do with the video. I just have to go on the video to share the link. And let me see what I'm doing here. Oh yes, if the stream goes offline for whatever reason, I'm using a laptop right now which is on life support. So if for whatever reason it just goes off and then the connection is interrupted, I'll be up and running shortly after, so do stay tuned. And I do hope the levels are okay. I hope that the levels and the quality of the stream is fine, because slight technical issues to do with the webcam. I couldn't have it online for now, but no worries, we still move on with things. Just gonna share the link online, so this will just take about a minute. Excellent. Yes, looks like I'm there. Alright, I'm gonna just update Telegram channel with the seminar, with this particular workshop. There we go. Alright, I've just updated the forum. Okay, so let's just get straight into this. Alright, might as well save this. Guys, welcome to this workshop. My name is Will, and I'll be hosting this particular workshop, which is now the Learn C# Masterclass. But it's in pilot, so that just means this is one of the first few of the series, and it's going to be great. You know, we're going to be taking a deep dive into C# programming and taking you on a journey to become a better C# developer, especially if you are just beginning, you know, if you are just starting to code. So this is going to be a continuation of the 2D game series. We've been looking at Win2D, as you can see on the left hand side, and I really do advise that you refer to the previous entries in this series, because a lot of this code, well, all of this code was written from the ground up, like line for line kind of thing. So you may be a little bit lost if you just kind of jump into the deep end. So you could watch the previous video, but I would advise you to start from the very beginning. This is the fourth entry in the series, so there's like 3 previous entries. Definitely go check it out, because we're going to literally hit the ground running, so to speak. What I'm going to do is just fire up this Visual Studio session. I'm going to fire up the game framework that we've been building, and we do have a bit of an agenda. Let's see if I can find it. So where did we leave last time? We got quite a few things done, and we managed to render some graphics to the screen. I showed you guys how to make a simple animation parser to basically very efficiently process graphics that have been loaded into memory as canvas bitmap objects. Let's see if I can find, and in fact I think it's right in front of me. No, these are just properties. So the animation routine is handled by one function, as you can see here, animate sprites. And it's quite a nifty piece of functionality, as you can see. All of this, what it does, you send in the parameters, you know, the sprite list as a canvas bitmap object, the frames of animation, within the slot. So basically, if you have a list, as I was trying to show you last time, like this, you can define what range you want to be animated. Maybe you want slot 2 to 6 to be animated out of your list, and such will happen once you plug it in. So it's very efficient. Do refer to the previous episode if you're a little bit lost there. So here's our scene. It's very simple, nothing exciting happening. We just rendered 2 different graphics, a bunny and a grass texture, as you can see. We do have some issues because before we actually had this bunny moving. It was animating in the idle state, so it was kind of swinging. The bunny was kind of swinging around. I'm gonna have to fix that in this episode. Hopefully, we can get around to doing that. But as you can see, as I'm using the D and the A keys, left and right, to actually move the bunny left and right. I'm pressing space to just pause the animation as well. And we have to deal with the ordering because what I want to do, just as a bit of a reference, I have no affiliation with Nintendo or Super Mario Bros. But what I want to do is kind of make a kind of new Super Mario Bros. Style experience, that kind of feel, that kind of vibe. I think it's a very simple way to start. My proof of concept is probably going to be a far cry from the tier of excellence that is New Super Mario Bros. But I think using that kind of game as a reference for a simple 2D UWP game is definitely does not go amiss. I think we had enough of seeing that. All right, so where did we get up to? Let's have a quick look. So we're gonna do this. We're gonna create a simple scene. We've already kind of done this, but I want to make the scene make a little bit more sense. I've noted here I want a parallaxing background. I did not prepare a background per se, so I'm gonna have to see what I can do to improvise that. Otherwise, it's just gonna be the white background you saw. I actually need to program a few more textures and stuff like that, or should I say some art assets I did not prepare. I should have got around to that. But anyway, what we can do, perhaps, if we don't do the parallaxing bit per se, because we're still going to be working on the camera, which kind of ties into the parallaxing effect, in that you need to have a camera functionality that sort of invokes a parallax effect itself. So we're going to be working on the camera first. I think that's a good place to start. We're going to be working on this. If not, then we'll do the parallaxing, and then we're going to work on simple physics. Let's see if we can fit this all in one video. Let's give it a shot. Okay, so we are right now kind of focused on the draw class. This draw class is where most of the animation magic happens. There's one particular function. And sorry if my Visual Studio does kind of get a bit slow. I don't have the fastest computer, but it does the job. I really love this laptop. What am I saying? So I have a function called animated draw right here, and everything pertaining towards the main render logic is handled here. So as you can see, we have some preconditions. If I'm clicking D on the keyboard, I'm rendering a particular kind of animation. If I press A, I'm rendering a particular kind of animation via e.drawingsession.drawImage function, and I'm also post-incrementing and post-decrementing the positions of the player character. Hence why when you press D, you increment by 4 units, 4 double to the right, and then if you press A, the player character bunny post-decrements by -4 double across the screen. Okay, so that should hopefully make sense. And then here we have the idle animation. Got to find out why the animation itself wasn't firing. As I said in the previous video, I alluded to the suspicion that maybe it's have to do with the way I'm constructing my rec structs. Still not 100% sure what's going on. The indexes probably not in. The indexes are probably not updating. What I'll do, I'll come back to that. What I want to really work on is the camera. So first things first that comes to my mind, that grass texture doesn't really make much sense floating in the air. I kind of want it to sit at the bottom of the screen, so I'm going to change its default value. So in order to do that, for each graphic you see on the screen, there's a bounding rect that holds it. And I have this grass rect struct. I'm going to go to its definition. And I'm going to find where I'm instantiating it, because there I'm giving it its value. And I think I was just there, I'm not sure. Oh, it's right here. Sorry, guys. So grass rect equals new rect, x, y, width, and height. So I have in this world coordinates static class, I think it's, or rather the grass width and height is statically accessed. I think the class is an instance class, I'm not too sure. But anyway, nonetheless, if I go in here, yeah, these are static objects in an instance class, which is completely fine. I've defined the grass width and height, but I want their positions. So I got X position and Y positions, public properties that expose private fields. So I've placed this grass texture in a position of 0 in the X, 140 in the Y. I'm going to put it up a little bit by increasing this number, but that's actually going to pertain towards the grass texture going down across the screen. Win2D, let's see if I can demonstrate this. So if I say something like 400, I might be wrong, but I believe that the higher the Y position number, so from 0 tending upwards, 0, 1, 2, 3, 4, 5, the graphics actually go down the Y plane. Let me see if I'm correct there. I'm not 100% sure, but I think that's the case. Okay, and what we should see, hopefully, if I'm not mistaken, is that the grass texture should be a little bit lower down the screen. I want to place it, make it a little bit more of a believable scene. The thing about games, video games as such, and other kind of like animated media, such as cartoons and anime, I'd even say, you're not really trying to go for a realistic look. You're more or less with a video game as an example. You're going for a believable look. You want to sell the scene, but you're not necessarily going for one-to-one realism. Even in the most quote-unquote realistic of games, it's always it's more the believability factor, isn't it? So that's a bit of a tangent. I just thought it'd be interesting to mention. So let's go back and have a look at this. Just gonna make sure the grass texture is in a slightly more suitable position on the screen. Wait for things to render. It looks like I overshot. So wherever the grass texture is, it's off screen, which tells me that I've actually gone a little bit too far with that 400. So what I'll do, you know what might be interesting? I am accessing this at runtime because I'm reconstructing my Rex, I think. I might be wrong, actually. I might be. I'm not sure if I'm correct on that. If I set a break, is this going to break? It does. I thought so. So what I could do... Oh, well, it won't parse if I even break the code, break the debug session, and then change this because this has already been defined. So I'm going to actually stop the program. And I'm going to just change the number to like something a little bit more suitable. Let's try like 210. Oops. And I'm going to fire the program and see what happens. Hopefully the grass texture is still on the screen. And then what I need to do is change the order because the grass was in front of the bunny, but in this case I want the bunny to be on top of the grass in front of it. And that's not a hard fix. I'll just write that down so I don't forget. Right. I'll just wait for Win2D to load up. I'm using UWP, the Universal Windows Platform, which is a very suitable platform for designing modern applications for Windows Target. Leveraging the prowess of UWP, you can write a single code base which you can deploy to multiple Microsoft products, Surface, Windows PC and such. I'm going to get rid of this break. I'm going to continue my debug session. And we have the grass texture. As you can see, it's sitting nicely over there. Moving my bunny across. So I'm going to make it a little bit lower because we have a bit of white space here. Kind of, as you can see, I'm kind of, setting the scene a little bit. And as I mentioned, the higher the number, do note that the sprite goes down across the screen. Counterintuitive to the sort of behavior of a traditional Cartesian coordinate system where you increment, you go up. In this case, you increment the y-axis, you go down. But when you increment on the x, you do go to the right. It's a bit interesting. I'm not sure why that's the case. It's probably something to do with hardware. I don't know. Let's add that by. Let's put that as 230. I'm gonna give that a shot. Okay, so I'm just waiting for UWP to load. Just taking a hot minute. Alright. Here we go. and stuff. Okay, it's probably gone down a bit. Hard to tell, but in full screen, obviously because of the responsiveness, it kind of looks like it has, but I'm not too convinced. I'll keep it on a kind of I'll keep it like this, maybe like medium size. So let me try and get that down a little bit more. And this is a little bit monotonous, so let me just kind of try and do this. Oops. Oh goodness, I'm on the wrong page. Let's just say 230, 40, 55, something like that, and that should do the trick. And whilst we're here, let's just sort out the draw order. So the grass is in front of the bunny. I want the bunny in front of the grass. So it all depends on the order of when you call drawing session. So for example, every time I'm drawing the what I have to do is get the texture for the grass and make sure that's being drawn last. Oh, sorry, no, make sure it's being drawn first, because what happens is that anything subsequently drawn on the screen will be on the top. Here, the drawing session for the grass texture, as you can see, render the grass texture, is at the bottom, which means it's rendered last, hence why it's at the top. So I want to actually look at this and place this at the top, like this. Render the grass texture, and really, you know what I want to do. Every kind of concern here, I'm going to try to implement them in a local function, and that will just help to keep things neat. So and that way I can kind of visualize a pipeline for what's going on here. Let's say something like void render, and let's say foreground, and I can just call these local functions in a pipeline fashion, which will help me just really visualize things. I'm going to collapse this so we don't have to look at it. Program the player movement, and I'll say void render player, and I have these if conditions, and I also have this as well, which is the idle animation. I'm not too sure. I'm having a try catch here. I should probably put a try catch around these as well, but I'll leave it here. I find that having isolated try catches for each concern is better than trying to try catch multiple concerns. I am guilty of try catching multiple concerns, but it just means that it's easier to debug your any try catch issues if you're isolating the code as narrowly as possible. That's what I find. So here we go. We have render foreground and render player, and if sprite sheet is not equal to null, and then we have that initialization logic. So what I'm going to do, whoops, I keep right clicking. This is a very sensitive mouse, but it's my fault. I'm going to call draw the foreground first. Oops. So I'll call render foreground, and then I'll call render player so that the bunny rabbit's at the top. Leave a little comment. I'll say define a simple rendering pipeline call for the scene as such. And let's have a look at what we got. Now I'm thinking to myself, should I have the camera logic in this class, or should I have it have a separate camera class? It's fascinating. I mean, for the sake of like swift or rapid application development, I'm thinking just use the same class. But I'm balancing that with the fact that I do want my code to be as kind of efficient as possible. But at this stage, I just need the code to work whilst making it slightly, keeping it well. So I guess I can always port logic into a separate class later. And this is the draw class, so it does kind of pertain. Draw update world coordinates. And we'll decide if I'm going to do that, if I'm going to have a separate camera class. I want to keep things as simple as possible at first. I want to really simplify everything. So I might just keep the camera class as a functionality in this class. Or I can define a class within this class scope. No, I'm going to just keep it as a functionality. Keep it really simple. Okay, what's going on here? Did I hit an error? Yes, I did. Now this is fine. It's the fact that let me just have a quick look at this. Render foreground. Now the thing is, it's just as I was saying earlier about having a try catch. So I need to put a try catch over this because sometimes I have a situation where my initialization logic hasn't fully passed the resources properly. That's what my suspicion is here. But if I go ahead and put a try catch, then I can make sure this exception is caught, basically. And then by the time the resources have caught up, then the render flow should not be broken. That's what I suspect from the previous workshop. I was having this issue as well. That's why I had the try catch in the render player somewhere there. So I do something like this. I put a catch on this try. And I don't have to do anything really here. It's just catching the exception. And I'll just see if I can continue with this. I'm not sure if it will go through. There are some threading considerations and timing issues, timing considerations to take into account. The Win2D documentation does talk about this. Is it working? There we go. We have a scene rendered. Obviously, there's still a gap here. We have to still deal with that. And I need to move the bunny down so we can actually compare that. Check if the bunny's at the top of the screen of the draw order. But so far so good. Let's see. I'll just do it like this a little bit. Kind of cheating, but just for the sake of it. And in fact, it's probably correct because, in a sense, because obviously the responsiveness makes a difference. So these are all things to take into consideration. But of course, we're just building the scene prototype right now, so it's not going to be fully polished. So let's bring the bunny down a little bit. I need to go to world coordinates, Y position, X position of the main player, which I suspect. Am I using different values? Because the top 0, 0 would pertain to the top left of the screen, I think. Where's the... I need to find the idle animation of the bunny. See what values I'm using. Okay, I'm using other values. I should change that. So X position is fine. Okay, so the Y position, I'm not using the Y coordinate, so I should change that. I missed that out, so... If I get Y position, access the Y axis, Y position, the bunny, and I just copy this, place it in in respective. Goodness, I got my word tied up. I just gonna copy and paste this where I need to. Y axis, overwrite that. Excellent. So now the bunny should be in an appropriate position. But now what I'm gonna do is actually change this. Because the Y position, okay, Y position is 255. Oh, sorry, no, I'm looking at the wrong thing. Y position is 0, so let's make it like, if the grass is positioned at 255, why don't we place the bunny at something like 270 and see what happens? Like this. Go back to the draw class. Okay. So I'm just waiting for this to load. I'm waiting for UWP to fire up. I think it's going to be quite fascinating to look at the camera stuff. When I was embarking on learning camera animation, like camera functionality, it was definitely very interesting to learn how different modes of cameras work. You'd be surprised how a camera in a game we take for granted like all the time, but there's a lot that goes into camera functionality. It's shocking. So I'm just going to wait for this program to load up. Obviously it's titled HD2D game demo. It's not exactly HD2D, but okay. So the bunny's down here now, which is fine for now. I'm going to lift the bunny up a little bit. Put the bunny a little bit higher up there. What coordinates? Let's go for like 64. It's a good number. I'll just stop this. Okay, I'm gonna trust that's fine for now before I fire up the program. Now, let's work in the camera, and I really do want to deal with the animation, but I'm gonna leave that till after the camera. So what I'm gonna do, I'll just collapse this local function, keep things neat. Now, camera functionality. Let's put it underneath this function. Now, camera. I think it might not go amiss to make it an instance class, because let's say you have a mode like split screen. This is just thinking ahead a little bit. In a split screen mode, when you play a game, you're gonna have two cameras working together, assuming you're playing in a traditional two-player split screen. Think of a game like Mario Kart Double Dash. Obviously, I'm not affiliated with Nintendo or Mario Kart, but just consider a game where you play split screen. There are two separate cameras working, separate to each other. So I think having an instance class is fine. Static would make sense as well, but forward thinking a little bit, I think an instance class makes even more sense. So what is a camera? A camera could be defined in many ways. In this case, a camera is simply a set of limits that we're going to impose, whereby we invoke parallax scrolling, and that's basically it. So let's see if I can illustrate this. First, we're going to take this off. So some space. If we assume this is our viewport, like such. All right. Use our imaginations a little bit. So this is our viewport. This is our screen kind of thing. And we have objects in our scene, right? Stuff like this. Now, what we want to do... I'm not doing that. Oh my gosh, I'm messing things up. So what we want to achieve here is this idea that we have, say, I don't know, we have player 1, and we want player 1 to move across the screen as such. So player 1 will kind of run across the screen, the bunny rabbit. The player playing the game will go across the screen to the right. But after a set amount, let's say just in the middle of the screen, maybe off center by a little bit, by a third or something, we want to hit some kind of boundary. So I'll say like boundary, like a camera boundary. So like camera bounds. And once we hit the camera bounds, we want to invoke parallaxing such that the viewport seems to be moving, as you can see. So the viewport will seem to move. You could consider, but then the player will kind of seem to be locked in place. So you have this kind of parallaxing effect where the backgrounds are scrolling, but the player stays in space, in the same space, it seems. How do we invoke this? Well, I would say a neat way to do this is to kind of define some bounds. So if we assume that 0 is the far left, 0, 0, xy is top left, we could say something like, okay, when the bunny hits, say, value 40 on the x position on the left, and maybe the camera bounds here would be, I'm going to change it to like 200. This is taking a wild guess. And I can have a condition that says, so let's say something like this. Camera, if player bounds exceeds or is equal to 200, then what we want to do is to invoke parallax effect like this. Okay, quite simple in theory. So what do we want to do? I think it might be neat to pass the values in the parameter. So I could say something like double x position, and let's say double y position like this. And let's have camera bounds as well. So I'll say something like double camera bounds left. So camera bounds left pertains to this left hand side, and then of course camera bounds right refers to this 200, this right hand side limit. Double camera bounds right. Now let's stick with just these overloads for now. And of course the player will be the object in focus in this scenario. So we're going to be comparing, say, the X position of the player to camera bounds on the right. This is going to lead into the idea of a world coordinate system, because what we're effectively doing, I'm going to specify implement a world coordinate system. And now why this has to be distinct to how we actually, in implementation, we translate the scene. So basically, if we're translating the scene via recstruct, so we can say recstruct x plus equals, let's say 7, right? That means we are moving to the right by 7 units of double. But if we have a scenario where we are translating the screen via parallaxing, then we might have values incrementing and decrementing, but we don't want that to pertain towards where the player is, because that might not necessarily be the case. And hopefully this will make more sense as we go. So what I'm going to do, and this might need a return value, I'm going to see. Or we might be working with globals. So if I go ahead and follow my pseudocode for now, I'm going to try and do things one step at a time. So if the player bounds, in other words, if X position that's been passed is greater, so if it exceeds the bounds of the limit, which is camera bounds right, then we want to invoke a parallax effect. Spelled parallax wrong, I think. And then this is another thing. How do we invoke the parallaxing? So I'm going to have a local function for now, void parallax. I'm going to make that p a small p. And the parallax, I mean, you can consider the parallaxing, when you really think about it, the parallax actually affects the background and the foregrounds. I would consider, for now, let's keep things really simple. Because we're dealing with just there's only 2 objects on the screen, the bunny and the grass, I'm going to have this return a double pertaining towards the X value of the target rect struct. We're going to need to pass the value itself, so I'm going to say X position, something like that. And for now I have Y position as well, just in case we are vertically moving. I don't know if I can even do that. I'm getting an error. Oh, it's the same one. So let's just say X. Let's just change that a little bit. Let's just say X position reference, Y position reference. I'm gonna quickly check on my stream, make sure everything's okay. See how I'm doing for time. Ooh, make sure everything's working. Sorry guys, I'm just checking my stream. I think I'm there. Yeah, I think I'm live. That's excellent. Sweet. I'm still here. Okay, so let's continue with this. So parallaxing, what I'm effectively doing is moving the background across the viewport to create the effect of parallaxing. So let's think about this for a minute. Let's assume we are moving either left or right. So I'm going to use a Boolean. I'm going to say moving, no, let's make it more specific. Player moving right. And I said double for some reason there. Let's make a bool. So if I use a condition and say something like if the player is indeed moving to the right, so if this is true, let's write it out so it's easy to read on first glance. Then I want to parallax in a certain area, in a certain position for the background. It will be opposite to where the bunny would be moving to create that effect. Otherwise, the vice versa of where the background will translate. Okay, so this exposition ref is going to refer to the background itself. So what I'm going to do, if the bunny's moving to the right-hand side, the background must move to the left. So I'm going to actually post decrement this by a certain value. And it shouldn't be hard-coded, but for now, I'll do it for the sake of time. Let's just say something like, well, we were moving by how fast for the bunny? If I go to the world coordinates, I think I just hard-coded it as like 8 or something. So let's just keep it as a hard-coded value for now, just to get things up and running. Otherwise, if the bunny is moving to the left, then we want to post increment the background. So I'm going to post increment by 8 like this. And I'm going to return the double. Wait, hold on. I need to make sure this is correct. Return 0. If that's even right. That's unreachable code anyway. Don't need that. Okay. Yeah, okay, I see how this can work. So if we're returning a double value, we just have to make sure we're post incrementing out of scope of this function. So I can just do like this. Goodness me. So I shouldn't be hard coding values. What I'll do, world coordinates, so I'm going to have a value called player speed. So something like private static double player run speed. Let's make it a value of 10. Let's make it interesting. 8 is fine. I'm going to have a public property for this. I'll copy this for now. I'll just copy this in like that. So now I'm returning the private field via public property. Sip on my tea. Okay, now I can access player run speed. If I go back to the draw core, I want to return world coordinate player run speed like this. Now the funny thing is, I mean, I don't need this precondition to be honest, but I'm going to keep it here because what I'm doing is somewhat, it feels naive, but it should still work. But again, I'm doing this step by step. And that might make sense as I go along, but this could actually be a more simplistic approach to what I had in mind before, the way I was doing this. No arguments. Okay, I need to fill my arguments. So let's see. Make sure I'm doing this correctly. I'm gonna have another overload. I'm gonna say exposition background. Make that double. I'll say double Y position BG for background. So that way I can pass exposition background, Y position background as well. I need to pass the boolean here, player moving right. I'm gonna set it to true. No, I'm gonna set it to whatever's being passed as an overload. I guess you can set it to null for if the player is actually no, okay, sweet. Let's have this here. So I'm passing a lot of values via parameter here. So if we breach the camera bounds on the right, then we invoke parallaxing. And if we are moving to the right hand side, we're returning a value. Now, this doesn't really determine the direction, which is what concerns me a little bit. The direction of the parallaxing is just returning a value of the run speed. But it might be fine because it kind of makes this more general purpose, which might help for extensibility. Because what I'm going to aim to do now, I'm going to call camera in my draw call. So every time I evaluate a frame of animation, literally a step in the animations, which is this whole block of animated draw. First I'm considering if I should render the previous frame or I should set parameters. I'm going to render the previous frame first before I set any parameters. So what I'll do at the bottom, I'll just keep the pipeline as is. Say something like void. Actually, there's no need for that because I've already defined the function. So here's my pipeline, render foreground, render player. Then I'm going to say camera. There's probably a good reason for where this logic should be, if it should be before or after, but for now I'm going to keep it here. Now there's an error because I need to pass the parameters. So for now, let's have a global indicating where the player is, like if the player has breached the right bounds or the left bounds. So I'm going to say something like double, I keep saying double, boolean, and I'll say, make it very simple, player moving, no, or rather, player invoke parallax, and this is going to be a bit weird because I'm going to say parallax right, as in the player's moving towards the right, so the background moves to the left. Hopefully that makes sense to me later down the line. I'm going to invoke it to null first. So it's none. Let's see if I can make it nullable. That's fine. I can make that nullable type now. So there's that. I'm going to pass this value. X position is going to be the position of the player. So I think it's called player rect. Player rect.x. Player rect y. Oops. I think it's the grass texture. It's grass rect or something like that. Grass rect x. Grass rect dot y. Camera bounds. Now I need to define the bounds of whereabouts the parallax is invoked. So these boundaries. So what I'm gonna do. Let's see. I'll say something like parallax bound right, parallax bound left, like this. Is it right or left or left right? Let me see. It's left right. This. Grab this. I'm actually going to create an object now. So, no, it's a rect struct. So it's a rect. And I mean, it doesn't have to necessarily be a rect struct itself. I guess it could actually be just a value, but having a rect means we are containing, in a sense, we're encapsulating the x and y values because we have x and y as properties for the rect, so it's just a tiny bit convenient in that respect. And I'm going to instantiate my rects. Might as well do it here. New rect. And I'm going to go to my world coordinate system and I'm going to define the bounds. parallax right bounds. I'm gonna stick with that 200. I'm gonna stick with 40 for the left. Like this. So that's 40. Alright, and I'm gonna make some public properties. So let's do like this. Make that capital. And I'll just copy and paste this. Now change it to left. Like such. Okay, so we have parallel left. Let's do this up wrong. Oops, I did that wrong. Should be like this. I'll just correct my syntax. There we go. Now we can publicly access the left and right bounds. Go back to the draw core. What's the correct overload? Be this one, double X, double Y, width and height. So X, the world coordinate, and it would be parallax. Ooh, goodness me. Because the left and right bounds actually have its own set of rects, boundaries. Let me not complicate this. Parallax left, but does that parallax left pertain towards this or this? That's what I need to specify. So I'm going to go back. I'm going to say parallax right bounds, and then I'll say X. So this is the x-axis for this, and I'll have the x-axis for this, just to make things a little bit easier to understand. Not that it makes too much difference to the functionality, but I think for my own reference it will make sense. Because I just want to focus on this right now, so I'm only going to be focusing on this. So I'll change that. I'm going to actually instantiate the parallax right bounds. I'm going to go to parallax right bounds x-axis. I'm being intentionally very specific. Now I need a y value. Now because we're dealing with the x value, the y value doesn't really matter in this particular case, depending on how we configure the camera. I'm going to keep it as 0. Width and height, you're not going to even see any graphics pertaining to the boundaries of the camera, so it's going to just literally be, these values don't really matter. Unless you want, for debug purposes, you want to illustrate where the bounds are. I could even do that. Maybe that's for another entry. But for now, we need somewhere on the screen that says 200 for this boundary. That's what we've done here. Now, I'm going to pass this in my overload over here. So, make sure I've got the correct rect. Which one doing this correctly? Yeah, that's fine. Parallax bound right. I'm accessing the x-axis of this rect. And obviously this value here, I've not really sorted out, but I can do it now very quickly. Let's copy this. Change this. I don't know if I even created this yet. So in this case, that should be 20, if I'm not mistaken. Parallel, oh sorry, no, 40 over there for the x value. Y value is 0, and it's got the same height width, which doesn't really matter at this point. Not that we're really processing the parallax bound left, but it's good to just keep it consistent. And I can place it here. And I'll just access the x-axis of the rect. Cool. Alright, things are swimming so far. What's this? Okay, so I'm going to just make this nullable so we can process the null value. Hopefully that fixes it. X position, so what's this? 1, 2, 3. I think that has to be nullable as well. Actually, yeah. Oh, what did I do wrong? Let me see. Oh, that was strange. Oh, it was just the IntelliSense. I thought I already wrote the question mark and I got very confused. Okay, so let's have a look at this. So if the X position of the player breaches the bound of the camera right, we invoke parallax, returning a value that pertains to where we're calling camera. And since we're returning a value, it has to be kind of respective to where the X position of the player is. So what I'm thinking, I'll take this out. I'm going to access player, render player. I'm going to carefully go to where we're moving to the right, which is when I hit the D key. And I'm looking at the X position, which is rendered here. It's always post incrementing, but this now has to be within a precondition. We have to kind of put that in a precondition because this can't just invoke when it wants. I'm going to take a minute to think about this. X position. So what I'm going to do. Oh goodness. Make some space. X. Make sure I got my overlays right. This is the Y position. I've got it wrong. Camera is void. So I'm going to return the double value. I'm going to return parallax. I'm gonna do, I want to specifically say if this is false, because I think I want to cater to the null value as well. Okay, that takes care of the situation. Alright, so because the parallax is returning a value, I need to be careful in that the post increment decrementation is now up here in the draw call. I think I've done this, I think I've over-engineered this. Just give me 1 minute, guys, to think this through. Okay, so I need to get the foreground. My fear is that I overdid this. Nonetheless, it should still be fine. We'll work through it. We can always refine what we're doing after we confirm everything works. Double X position. Because we're sort of evaluating the scene twice, but you know, at this point I just need to get it working, then I can refine and optimize things. Grass rect X. Grass rect Y. Camera browser be world coordinates. Parallax right, X. Should be left. Oops. Didn't know where I got to. Left. All right. So let me review what's going on here. I hit the D key. I do a check to see if the X has breached the limit. Then I draw the player, but what I'm doing differently is that the player shouldn't move. The player should be locked in, hence why X axis is 0, which is wrong. It should be a post decrement of 0 pertaining to where the player already is. So I'll say world coordinate. I think I have a player parallax. Player rects dot X. So I'm not going to post increment nor decrement. So I've locked the player into this. I've locked the player character in place, whilst at the same time I'm parallaxing the foreground or background, depending how you look at it. So I'm passing the sprite sheet grass texture into my animate sprites. I'm invoking a new grass rect. I'm now invoking the camera function, which is where the redundancy comes in a sense, because I'm doing a second check, so I really have to optimize this after. And I don't want discrepancies to cause issues, but let's just see what happens. Invoke parallax. I got the workflow down at least, which is good news. Parallax is here. If player moving to the right is true, then I'm returning a value. Now, where that value is returning, let's see where it is. It's here. So we need to make sure we're doing a post decrementation. So it's going to be the grass rect dot X minus equals the return value of the camera. Alright guys, I'm trying to do this as carefully as possible because I did confuse myself, but looks like I might be on track. I need to test it out to see what's going on. So I'm going to save that one more time. I'm going to hit play. Let's see what happens. I don't think I accounted for simply moving the rect before parallaxing. If player X greater than or equal to, because if this if statement falls through, then I need to increment the player x-axis accordingly. So I'll just wait for the program to boot and then I'll sort that out. I always find when it comes to programming cameras, in my mind, it's like it's so simple to program cameras. And it kind of is. That's why the practice helps me. But then in practice, no pun intended, it usually takes a lot longer. This is like the nature of coding itself, I find. Let's quickly see off screen how I'm doing for time. Okay, we just passed the 1 hour mark, so I'm going to look to see where this is going and if we're going to wrap up soon or not. I want to at least get this functionality working. I haven't broken too much. There's the bunny. Now the bunny's probably not going to move yet, and I'm going to, before I even test it, I'm just going to put a break here. But not to hit D. Okay, I understand. So this is falling through. Yeah, so nothing's being rendered. So what I'm going to do is else. I'm going to get this. And I'm going to render the player character. X post increment by world coordinate. And it's going to be player run speed. Okay. Get rid of this. And let's continue. There we go. It's really fast. Now, as you can see, we're having a bit of a glitch. Let's see what's going on. This is the bounds. Quite clearly, that's the bound. But the bunny seems to be disappearing, and there's no post incrementation. So what I'm going to do, it looks like we are invoking parallaxing. I might be wrong, let's have a look. There we go. So this is, now you can see the code has the debug session just broke. So we've invoked parallax. But now we just have to make sure the logic is correct. So the bounds is 200, as you can see there. So I have to make sure I'm drawing things correctly. So player x, what's player x? 204, that should be okay. Fascinating. Let's step through and see what's going on. Okay. Get out, step out. Now this is what I'm really concerned about. Grass rect x 0. Now I have to make sure this is returning the correct value. Let me put some stuff in my watch list. Grass rect, so we can observe what's going on. So x is still at 0. I'm going to step through line by line. Well, not this animation part because we don't need it, but rather it's the camera call I want to look at. So if x position, which is the bunny, exceeds 200, returning parallax, x position is 0. That's what I got wrong, I think. Let me see what I'm doing. Let me first evaluate what I'm doing before I change anything. So if moving right is equal to true, it's null. So I need to make sure. Oh, okay, I forgot to update this. So because we've invoked parallaxing to the right, I have to just make sure that I change the boolean, I update the boolean. So I'm going to go up here and assign the boolean to true. Because of the way I did things, so I'm going to exit the program, or rather exit the debug session. That's out of scope, because that's the wrong parameter. It's up here somewhere. I don't even know if I did that right. It's this. global reference. And get rid of this breakpoint. Indicate that the player is parallaxing to the right. Okay, let's have a look at what happens. Because now we shouldn't fall through to this contingency. We should be evaluating this run speed being returned, which is okay. Let's have a look at what happens. I'll just wait for UWP. Okay. Wait for my session to load. Okay. Okay, so we have a bit of movement. I don't know if you caught that. The scene did move indeed, but not correctly. So I need to see what's going on. Fascinating. Very fascinating how this is working. Okay, let's see if I can fix this. Where am I? So I'm gonna put a break here. I'm gonna attempt to parallax. There we go. So if player moving to the right is true, which it is. I'm returning player run speed. And I return parallax, which is player run speed. So now the grass rect, I think I'm overwriting this. That's what my suspicion is. So as you can see here, grass rect is now at -8. But am I drawing the grass rect somewhere else and overwriting what I'm doing? I don't know. Player rect, player rect, player rect. Okay, render the, let me see what's going on here. So here we go. That's not going to go through. That's not going to go through. For some reason I'm pulling parallax again. I'm not too sure why that happened. Let me just have a look at what's going on here. So it seems like grass rect has reset to 0, the x value. I'm not too sure why. What I'm going to do, oops, I'm going to look at where I'm updating this. So I'm going to find all the references. Maybe there's somewhere I'm resetting that to 0. Grass rect. It's being assigned to the default value here. Render foreground. Ah, maybe it's this. This animation. Okay, that makes sense. Because I'm rendering the foreground in its own place, but it doesn't really make sense because I'm rendering the foreground somewhere else. Many ways I can approach this, so I'm going to comment this out for now. I'm going to look down here where I'm invoking the parallax effect. So if I'm invoking this, and then I'm going to just simply grab this. So when parallaxing is not invoked, I still want to render the graphics. This. But instead of passing the default value, I'm just going to pass the current value. So I'll say something like grassrect.x. Continue. And I'm going to see what happens. Cross this out. Wow, getting some really, okay, that's a strange error. Just gonna wait for UWP to load. Okay. I was looking away from the screen. Ooh. So, get rid of this break. And as you can see, we have parallaxing. Now it's a little bit broken because obviously not every contingency is being accounted for, but I'm going to just demonstrate that one more time. So the background does parallax. It's a bit glitchy for many reasons I have to account for, but we have the parallaxing. I have to sort everything else out in the scene. But for now, guys, I'm going to leave it here because we're on the 1 minute 18 mark. And I thank you for watching this particular entry. Oh, you know, look at that. The animation of the bunny's fixed as well, which is amazing. Not when he's running, but when he's idle at least. So I saw it's something out there too without even knowing. So guys, thank you for tuning in. I'm going to cross this out. Just going to make sure I save this. And yeah, so once again, just draw your attention to the one-to-one C-Sharp mentoring scheme and the Learn C-Sharp Masterclass. If you're interested, register your interest. You should see some links in the description of this video, the stream archive for both of these, hopefully. It should be there. And my official Telegram channel for this masterclass should be online as well. Thanks for watching, guys. I really do appreciate the support. And yes, I bid you all a great day. Take care. Bye for now.